Okay, 9.1 is, oh, I changed it to 9.2 on my table of contents. My bad. I am so sorry. I just noticed it. Okay, so 9.1 is area of plane figures, which is really just a fancy way of saying anything that's flat. And we're going to focus on quadrilaterals, special ones, and triangles. Not so special triangles. So when I say quadrilaterals, I'm talking about parallelograms, trapezoids, and kites and rhombuses. So I'm talking about those ones first. We're going to start with the most basic of them. Today's the 20th. The most basic quadrilateral that you know the area of. What would you say that would be? Starts with a P. Ends with an parallel. Yeah. Yes, parallelogram. What's the area of a parallelogram? Something times height? Something like that. Okay, go ahead and draw it to the best of your ability, a parallelogram. It's okay if it doesn't look as good as mine. I've had a lot of practice. You're going to need the height and you're going to need the base because the area is blank times blank. What times what? Base times height. So I've got my height right here and I've got my base down here. The base and the height always meet at a what angle? 90-degree angle. They always meet perpendicularly. So keep in mind that your base and your height have to be perpendicular. Another thing that you should note is that the opposite sides are still going to be congruent. That has not changed. Not only are they congruent, but that they are parallel. That's what makes a parallelogram so special. There's a lot of other things like angles, properties, all that stuff. But we know that the area is base times height. Every time we use a formula, you are going to write it down because we will need these formulas later on and it gets really overwhelming. I'm sure you remember learning all this stuff and like having to remember all the formulas was really confusing. So let's go ahead and do an example. Go ahead and make another parallelogram. For this one, I'm going to say this guy is 13. I'm going to drop down a little doohickey right here. And I'm going to say that I know the whole thing right here is I'm going to say this is 8. And this bottom part is also 13. Okay? Do I have all of the information to find the area? Okay, so what's the base? 8. 8 is the base. I'm going to drop it down to the opposite side in case you've not already drawn it. Make sure you do that. So I know this part right here is 8. Do I know the height? Nope. 13 is the slant height. 13 is going to help me find the height though, because again, I know that the opposite sides are congruent. So I know that this side is also 13. I can find the height by making it into what type of problem? A Pythagorean problem. Very good. Okay, so I got to find the bottom chunk that I don't need. I know that my base, I know that my Formula is base times height, so I know my area is going to be 8 times something. I got to figure out what that height is. So how do I do that? Minus 8 by 13. That gets me 5. Well, I'll be darned. That is a Pythagorean triplet, so it should work out really, really nicely. Let's go ahead and label our h and find h. Is h one of my sides, my legs, or is it the hypotenuse? It is one of the legs. Do I have the other leg? What's the other leg? Yep. And then my hypotenuse is the slant height. Yep, slant height. I know that's 25 and I know that's 169. Subtract that bad boy over. We get 144. Check me on that. Square root, we get 12. We're very quiet. Okay, so that's 12. How do I get my area? 8 times 12. That one I do need my calculator for because I don't remember it. I get the answer. What did you guys get?
96.
I got 96 as well. We don't have the units, but let's say if I gave you the units were inches, what would be my area unit? Inches, I heard it. Squared, very good. I heard it whispered. I heard a whisper. Okay, very cool. Questions on this? No? We're going to build off that. So do you want to do a trapezoid or a triangle next? Trapezoid. Okay, cool. So a trapezoid, I don't know if you remember that formula. That formula is kind of funky. I'm trying to keep my notes relatively organized. Okay, so we got a trapezoid. So a trapezoid, go ahead and draw it. It's different from a parallelogram because it only has one pair of parallel sides. So you only have to worry about one pair. But we can derive meaning we can like figure out the formula by using the parallelogram formula. So I don't know if you've learned this before. It's one of my favorite little tricks to show you. So that I know that I have two bases of a trapezoid. The legs don't really matter right now. So I have base 1 and base 2. I can control copy and then flip it upside down. So I can rotate it upside down, or not rotate it. What's it called when you flip it over? Reflect, thank you. I honestly did not remember that word, so I appreciate you guys. I'm going to control copy and reflect this little doohickey over. So I'm going to measure out with my fingers relatively where, with my fingers if I can, relatively where base 2 ends. It's okay if you don't do it exactly. So base 2 is right there, thank you. And then I'm going to do the same thing. I'm going to measure out with my fingernails. Base 1. I don't know if I did that one okay. Yep, you're copying it and reflecting it over. How cool is that? And now what did we create? A long parallelogram. We actually created a parallelogram. So Isn't that cool? You can lie to me and say, yeah, that's really cool. Okay, so the area is going to be, the area is equal to, I'm going to leave a little bit of space. I guess I don't need to. It's base times height, but your base is added together. So it's base 1 plus base 2 times the height, and there's 2 of them. So what do we have to do to get rid of the extra one that we don't need? Divide by 2. So sometimes you might see it like this, base plus base times height divided by 2, or you might just see it as 1/2 base 1 plus base 2 times the height. But that's how we get the formula. You have to add the 2 bases times the height and then cut it in half, because otherwise you get double the area that you want. Is that terrible or is that okay? I think it's okay because you guys are being really quiet right now. Let's do an example. Okay, so for my example, I'm going to give you a lot of information, but you need to find the missing piece of information. So I'm going to give you that this is a right trapezoid. I'm going to give you that the height or one of the sides is 10. I'm going to tell you that the bottom of the trapezoid is, I'm going to tell you that these guys are parallel because mine looks a little wonky. Remember that the arrows mean parallel, that they're parallel to each other. I'm going to say that this is 18 and my units are centimeters. I'm going to give you that this one is 13 centimeters. And I actually give you that the area is 160 centimeters squared. And I want to know what is the perimeter. How would you do that? What the heck? What do you think? I'm actually really proud of this problem. I think it's an excellent problem. How do you get perimeter? Yeah. Add all the sides. So I only have 3 out of the 4 sides. I need my last side. So we gotta do what? Not Pythagorean theorem. That's only for triangle problems. And actually, could I use Pythagorean theorem? I think you could. Oh my gosh. I did not think about that. That's a clever way to figure it out. But no, we're not going to use Pythagorean theorem. We are going to, because it doesn't actually work that way. My bad. I did not do my math right. If I was Pythagorean theorem, that would have to be a different number. Anyways, I estimated. So we're not going to use Pythagorean theorem. We are instead going to work backwards using the area formula. So we know that area is this. I'm going to write it down. Remember, every time you use the formula, you write it down. I'm going to do base 1 plus base 2 times the height divided by 2. Okay, so I have what information? I have base 1. Do I have base 2? No, I'm missing one of my bases. So I'm just going to call that B for base. Let's go ahead and, what's my height? 10, yeah. My height is 10. Let's go ahead and plug in the information that we have. We do have the area. So I'm going to plug in 160 equals, and then we're going to do base plus 18 or 18 plus base times the height, which is 10, and then divide it by 2. Can we, okay, let's look at this. Can we simplify anything? You can divide 10 by 2, which is 5. You can either distribute the 5 or divide by 5. Can we divide by 5, please? I don't want to do extra work. I'm feeling a little lazy. I'm typing that in my calculator. What is 160 divided by 5? It is 32. And then subtract 18 on both sides. So my base would be, because I want to get rid of the other base. What is 32 minus 18? 14. Okay, so that was my missing base. Add up all the sides. That will get me my perimeter. So my perimeter would be 10 plus 18 plus 13 plus 14. I also got 55. And what would be your units for perimeter? Not squared, centimeters. You're good. Just centimeters, because it is a length. Very cool. Questions on this? Okay, I got room to do one more on this page, and then I'm going to flip to the back. If you don't have room, that's totally fine. I just wrote really big. So we did trapezoid. That's one that we can derive. We can also derive a triangle formula, which, I don't know, do you guys remember the triangle area formula? Yep. And the reason why we get that, base times height divided by 2, is because a triangle, literally, you can do the same thing for this guy that we did for trapezoid. So triangle, go ahead and draw just any kind of triangle. Mine kind of looks like it's equilateral, but it's a trick. It's not really. There's my height, and here's my base. And I'm just going to take my base and copy and paste it up here. So I'm literally taking this guy right here and copy and pasting it. I think that's where it is. So that's my fake bit. I do not want this. I just want this guy right here. So your area is base times height divided by 2. Because you don't want the extra bit that I added onto it. I think I can squeeze an example down here. I don't like that I keep drawing acute triangles, but whatever. It's the choice I made and I'm committing to it. Let's do 15 centimeters. And let's do 12 centimeters. What is the area? There you go. Easy peasy. 15 times 12 divided by 2. It's a big number. Maybe? 15 times 12 divided by 2. Oh yeah, that's kind of what I was thinking. What did you get? 90. Yeah. 90 what? To what power? Because it is area squared, not cubed. Cubed is for volume. Just centimeters would be for the regular stuff. Okay. So we did parallelogram, trapezoid, triangle. The last bit of information is for the same type of problem, which is kind of funky. Or no, sorry. They use the same formula, but they are not the same. So it's for a rhombus and a kite. Funnily enough, a rhombus and a kite have the same formula. Do you think there's anything in common between a rhombus and a kite? It's something about their diagonals. I'm going to give you a hint. Rhombus, kite. So for a rhombus is a special parallelogram. It's a special parallelogram because all of the sides are what? Congruent. They're all equal. So this formula actually deals with the diagonals. Go ahead and draw your rhombus and draw in your diagonals. Am I going too fast? Or are we okay? Okay. Just let me know if you need a minute. You guys are locked in. I greatly appreciate it because I know it's hard to do that right after spring break. There's no time to lock out. Exactly. Okay. I don't know. I'm trying to draw a kite as best as I can. Kites are a little tricky to draw for me. So kites are different because not all of the sides are equal, just two consecutive sides, like this and this. Again, their diagonals have the special property. I'm going to go through and highlight my diagonals. There's one diagonal. This might have been a mistake. There's the other diagonal. Okay, so the formula is kind of funky. The area formula is, oh gosh, I think I want to double check it. I believe you multiply. This is what happens when I don't remember the formula. Yep, I was right. Okay, so your area is diagonal 1 times diagonal 2 divided by 2. And the reason why these guys use the same formula is because both of them have diagonals that are perpendicular. So if you remember that the diagonals are perpendicular, you can remember that they both have this one in common. It's kind of crazy, right? Or are you guys just being like, it's not that crazy? Okay. For this one, I'm going to draw a kite as an example. My diagonals. There we got it. I'm not going to try and make this one pretty. I'm just going to give it to you guys straight. This part of the diagonal is 3. This part of the diagonal is 10. And I'm going to give you this guy right here. Actually, I'm going to try and make it work nicely. Is 5. So we're missing part of it. And I'm going to go ahead and put an X there. And I'm going to ask you for diagonal 1. I'm going to ask you for diagonal 2. You'll have to find x first, and then I'm asking for the area. But in order to find the area, I got to figure out which one's the diagonals. It is 6 is one of them, not 15. So how did we get 6? So we know that this diagonal is the same on the other side. Okay, so we know that one's 3. That side would also be 3. So one of the diagonals is 3 plus 3, which is 6. We would use Pythagorean theorem. We need to get x. In order to get the longer diagonal, we're going to have to do, it's going to be x plus 10. It is, because it's a 3, 4, 5. It's a 3, 4, 5. If you didn't know that it was a 3, 4, 5, we can go ahead and use Pythagorean theorem. Make it a right triangle problem. I'm going to go ahead and show the work for it. That's not bad, right? I was nice to you guys. Do you feel like this was not nice? Huh? It is long. We're done though. So any problem that isn't like an immediate solve for it is gonna feel like kind of funky, kind of long, but trust me, it's worth it once we get the answer. It's like the best things come to those of us that wait, right? So my area formula again, you just multiply the two diagonals, d1 times d2, and then divide it by 2. So we would do what times what divided by 2?
4
We got to add the 4 to the 10, remember? Because the diagonal is 14. So it is 6. 6 times divided by 2. Okay, 6 times 14. I want to say that's 96, but I don't think that's right. Oh, 84. Yeah, not at all right. Silly Miss Mark. Okay, 42 is what I get, the answer to the universe. I don't think I gave you units, so we would just say units squared or just 42. I'm going to just say 42. Questions on this? No? Okay, so you have classwork to work on. The classwork is just for class, and then there is a homework assignment that I'm going to post on Google Classroom that is a Google form, okay? So it's going to be different. I'm actually going to post it right now, but I am expecting you to do at least most of the area of plane figures worksheet. I'm going to stop this here.